Hello, everybody. The purpose of this video is to show how the MP-AES, ICP-OES, and the ICP-MS data can be understood and exported. So the outline of this video, we're going to go through the software. We're going to later see how to know if data is valid or not. Then we're going to go for being able to discriminate between a good peak and a bad peak. And at the end, we're going to see some export options. So let us start with the software. So the software that we're using is from the manufacturer Agillent. So we double click here, and we're going to open the software. I already did this before because this is going to take a couple of minutes to open. And whenever you open, you can select a file you want. So this software is very similar. I have worked with MP and also with ICP, and the software is extremely similar for both. There are going to be different functions for the ICP, probably more functions for the ICP because it's a more complete equipment if you want, or more advanced equipment. But essentially, it look extremely similar. So we covered the software a little bit. Now we're going to go to how to know when a value is valid or not. So it is important to know that the ICP or the MP are going to need some standards. In theory, you will only need one standard because you have the origin always, the blank. It's going to be 0, 0. And then you can, if you have another point, you can make a line. This is assuming that you're going to have a completely linear relationship. But unfortunately, that is not always the case. So people usually recommend to use at least two standards to do this, if not three. In this case, and in most of the cases, I try to work with three different standards. In this case, we're working with 500 ppm, 750 ppm, and almost 1000 ppm. And we're working with two different wavelengths because we are developing a method. So we want to see which one is more accurate. So once we have this, we want to see which of these data are valid. And the way to do that, we have to go here, that I think the default is concentration. So we have to click here. We're going to have intensity. We are going to click there again, and we're going to have the unadjusted concentration. And that's what we care right now to see if the data is going to be valid or not. So as I said before, we don't have a completely linear relationship between the intensity and the concentration. But if you have three standards that are relatively close together, you can expect them to describe very accurately the actual concentration that you are having. Therefore, and to have a very objective way to discriminate valid and not valid data, we are going to say that any data between the lowest standard and the highest standard is going to be valid. So in this case, we have 500 ppm as the lowest standard and 983 ppm as the highest standard. So as you can see, maybe this data wouldn't be good to be considered valid data because it's very low in comparison to these three standards. But if we go down, we can see that these two data are very accurate. Why? Because they are between the two standards, the lowest and the highest. So once we have that, we can go to concentration. And we know that this is going to be concentration that is relatively good. So what's the difference between the concentration and the unadjusted concentration? So if you go to sequence, you're going to see that you have correction factors, the weight of the sample, the volume of the sample, or the solution, and the dilution that you did. So for example, in this one that has the three of them different than one, we can see that the initial weight that we used was 1.9 grams of a solid. And then we diluted that in 100 milliliters of total volume. And then after that, we had to do a dilution of 1 in 266. So that's the difference between the unadjusted concentration and the concentration, the corrected concentration, that the unadjusted doesn't consider these correction factors. So they are both very useful because the unadjusted concentration lets you know if you are between the standards. The actual concentration gives you the value of that concentration that you before said that it was valid. So if we want to export this data, we can just go select the data and right click, and we go to copy with headers. And then we can go to an Excel document and we can paste. So we're going to have the headers, but we are also going to have the values. And you can do this for the intensity and the unadjusted concentration. But if you already discriminated that the data was valid, you can just copy the concentration values. Now, how can I get even better results? Because right now we just know that this is like an acceptable data because it's above 500 and below 1000. But something that we can do is the following. We can go to blank subtraction and we can, it's usually turn on, sorry, by default. So if you see here, like this is the blank, we expect is pretty much 0 because it's below 1 pp, 1 of intensity, sorry. But then when you go to the standard one, you can see 90,000 intensity signal. And this one is also very high. This one is very high. And they are proportional to concentration. So we can say that they are valid data just looking at this. However, if we turn off the blank subtraction, we're going to see that the blank is not completely flat. The blank is the line that you can see here. Now, something interesting is that we already corrected this because when we started doing this, we were going with 33 ppm standard, 66 ppm standard, and 100 ppm standard. And as you can see, there's no peak. So at the end, what my equipment is measuring is the difference between the blank and the signal, but there's no like a clear peak. So because of that, we started using standards with more concentration, as this one. It's a better signal. And we have a high concentration in our samples, so we can do that. So that's a way that you can see if your peak is good enough or not. There are situations where you cannot have a better signal. So you can do other tricks. For example, you can do the spikes method that is pretty much doping a solution with a known concentration of a certain element. So that way, when you have the final result, you just subtract it from the known result, from the known concentration. But probably it's very complex and will require a whole video about that. Now we're going to talk about export options, although we already kind of talked about that because we saw how we can copy with headers. So there's another way to do it. We can generate a report. So when we generate a report, we need to select a type of report template. You can select this one, for example. We put open. This is the report that we're generating. And as you can see, it's a very comprehensive report because you can see the calibrations, you can see the standards that you're using, the intensity of each standard. And then, of course, eventually, you're going to be able to see the results that you got. Here you go. Analyze results. So this is another method to do the same thing. It might be very useful if you have a lot of data, but if you have very little amount of data, very few values, it's probably better to validate one by one. So that way you only export the data that you know for sure that it's correct. So this has been everything. Please let me know if you have any questions.